Vanakkam. Welcome to this video on classics in neuroscience. We have been looking at chemical signaling molecules or the first neurotransmitters in the brain. In this video, we will be looking one development in methodology that helped resolve the controversy or the debate between the soup and the spark that we saw in the previous video. The neurotransmitters in the brain, or what were the neurotransmitters in the brain that were understood to be present in as of the 1950s, and what are some of the criteria that have to be met for a chemical to be considered as a neurotransmitter. This was by Eccles, and another statement by H. Dale that came to be called as Dale's law. So, after these debates between the soup and the spark, just after that there was this development of glass micropipette that was used as an intracellular electrode. That is, this electrode could penetrate inside the cell without destroying the cell, and we can observe activation or electrical activity or electrical response at the level of the junction. Remember, this is in stark contrast to what was being performed before this. What was being performed before this was at the level of organs, that is, you stimulate the vagus nerve and you see that the heart is slowing down, or you stimulate a muscle and you see that the muscle is twitching. This is at the level of the organ or tissue. Now you are having an opportunity to study the electrical activity at the level of the junction. So, this helped resolve many of the controversies or many of the discussions that happened previously. This was a very important methodological advancement. So, in the 1950s or the beginning of 1950s, what was known about neurotransmitters? So, in the 1950s, electrophysiologists were studying activity using intracellular electrode or the microelectrode that we just discussed. They were studying activity at the junction or at the cellular level, They were also studying physiology and pharmacology that happens at the cellular level. And biochemists and pharmacologists were attempting to identify the chemical mediators or the neurotransmitters, the chemicals. And when we look back to 75 years before or 73, 74 years before, it would be absurd, right? What were these guys doing? They had absolutely no clue what was happening. I mean, today in contrast, we know about acetylcholine, we know about glutamate, we know about adrenaline, we know about epinephrine, norepinephrine, we know about serotonin, we know about dopamine, we know about so many different neurotransmitters. What were these guys doing in the 1950s? It's really weird for us to look back in that age and look how much knowledge was lacking, the paucity of knowledge. There was this knowledge gap. How much was this? Right. Remember, at that time there was really no field of neurochemistry or biochemistry of the brain. There was no such field, there was no journal, there was no textbook, there was nothing. Practically it was an open field. Practically there was nothing. There were textbooks of biochemistry, but there was no specific textbook of biochemistry of the brain. There was no textbook of neurochemistry and other such things. There was no textbook, nor was there even scientific journals dedicated to this field. One interesting example comes from the 1955 edition of the textbook, The Pharmacological Basis of Therapeutics. It's a textbook. What were the neurotransmitters that were mentioned? Acetylcholine, as discussed in parasympathetic autonomic action, norepinephrine in sympathetic autonomic action, glutamate was mentioned as linked to treatment of epilepsy, some important neurotransmitters like GABA was not even mentioned, dopamine was not mentioned, serotonin was not mentioned. That is all that was known in the early 1950s, that the mid 1950 textbook or 1955 textbook only mentions a few neurotransmitters and does not mention many neurotransmitters that we now consider important. This was it. This was all that was known about neurotransmitters in the 1950s. Now, if you look back through the course of 1950s, that from 1951 or from 1950 to 1960, a large number of these neurotransmitters were identified and their functions described in relatively good detail, which is why 1950s happens to be this golden era for neuroscience. So, in the 1950s and 1960s, because there was considerable debate about the nature of neurotransmission, some specific criteria were mentioned about the chemicals that satisfy only these criteria went on to be considered as neurotransmitters. This was defined by Eccles. He said there must be appropriate enzymes for synthesizing the transmitter in the presynaptic terminal. So, there must be some evidence suggesting that this chemical or this particular messenger chemical mediator must be synthesized, or the presynaptic neuron must be able to synthesize this chemical, and there must be sufficient quantities of this substance in the presynaptic terminal, and upon stimulation of this neuron, sufficient quantity of this chemical must be released. Also, if I am able to artificially apply this chemical at the junction, I must get identical response, identical action, and if I am synthesizing this pharmacologically and naturally, and the comparison between the two when applied must yield identical pharmacology, and there must be some mechanism that inactivates this substance. These were a set of very rigid criteria. Even in the peripheral system, it was quite difficult for all these criteria to be satisfied for neurotransmitters, but some of the synapses in the central nervous system are remote or hardly accessible. It's next to impossible to access some of these synapses. You cannot show all of this, you cannot show evidence for all of this. So this was a relatively challenging set of criteria to be fulfilled, but this was the criteria that was set by Eccles. Later, H. Dale asked the question that about regeneration. I am going to read from the text. The phenomena of regeneration appear to indicate that the nature of chemical function, whether cholinergic or adrenergic, is characteristic for each particular neuron and unchangeable. When we are dealing with two different endings of the same sensory neuron, the one peripheral and the concerned with the vasodilatation and the other at a central synapse, can we suppose that the discovery and identification of a chemical transmitter of axon reflex dilation would furnish a hint as to the nature of the transmission process at a central synapse? The possibility has at least some value as a stimulus to further experiment. That is, he suggested that if a particular axon was releasing a particular chemical in one end, it is going to release the same chemical in all of its ends, regardless of where it is synapsing it. So, inference of a transmitter at all synapses made by a given neuron, if it is established at one synapse, this is going to be the same in all the synapses. Remember, the response in all the synapses need not be the same, because the response depends on the receiver. This applies to presynaptic unity, not postsynaptic actions. Remember what I said. How a given person responds to a situation depends on that person, but the situation is what is provided to them by the universe, whatever, right? We were discussing Viktor Frankl's statement. So, this applies to presynaptic unity, but postsynaptic reaction depends on the particular receptors. This idea was named as Dale's law by none other than Eccles. Eccles called this as Dale's law. With this, we come to the end of this video. In this video, we saw the use of intracellular electrode or the micropipette based recordings that enabled study of chemical mediation and electrical activity at the level of junction and at the level of cells, and identification of neurotransmitters in the brain, and criteria for identification of neurotransmitters as defined by John Eccles and as suggested by Dale's law. With this, we come to the end of this video. Thank you very much for your attention.